Bismillahirrahmanirrahim. Hope you are fine. So let's start with this third lecture. And actually this lecture is in continuation of our last lecture that was about liquid extraction equipment. So just to quickly recap, yesterday we started with the liquid extraction equipment. Before that we have just discussed briefly what liquid extraction is and how does it proceed, what are the stages involved, and then yesterday we started with liquid extraction equipment, in which you have seen some basic introduction about the equipment, their types, like their static, dynamic, as well we discussed spray column, then there was pack column and sieve tray column, if they are used for like liquid extraction. As you know, these equipments can also be used for other application like distillation, absorption, but here we are discussing them for liquid extraction. And we have discussed several of their advantages. So out of those there was one called mixer settler. So that was some dynamic device that was agitated, that there was some shaft and there were some impeller or agitator connected to that shaft for creating agitation. So this lecture is I think majorly about those equipments which involve some mechanical agitation. So here we will discuss mechanically assisted agitation devices. Either sometimes they are packed or tray tower, they can also be agitated, but mainly those will only involve simple columns and with agitation devices. So let's look at them before I proceed with their further details. So quickly look when we need this mechanical assistance, or why we go for such kind of agitation, as we discussed that there are spray tower or packed or sieve tray tower. So they were quite good in their performance, but still there are few problems which you have to overcome when you are working in industry. So what are those problems actually? As you have seen that in all such kind of columns, we discussed that in liquid extraction equipment there are like counter current flow between two liquids. One is heavy and other is lighter one. Usually lighter is introduced from the bottom of the column and heavier is introduced from the top of the column, and when they move in opposite direction to each other, they come in contact and mass transfer takes place, or extraction which you want to do takes place. But sometimes these gravitational, why they are moving in the opposite direction, actually we are just bringing them in contact, and they have different densities. There is a density difference, and due to this they are usually moving in like lighter one definitely will move to the top and the heavier one to the bottom, and this is due to the gravity. But these gravitational forces are sometimes not sufficient in aggregate for proper phase dispersal and this turbulence creation, so that this separation can take place. This usually occurs, or these gravitational forces didn't help us, especially in some specific cases, like if interfacial tension is high, surface tension between two feed and the solvent which you are bringing in contact is too high. So in that case, when the surface tension of one liquid is higher and other is also higher, so they will not properly mix with each other. Turbulence is not better between them, and they didn't make better contact, so less mass transfer definitely. And the other problem, density difference between liquid phases is low. You know what will happen if two liquid have more or less same density? So no more contact. Suppose you introduce lighter from the bottom and top from top heavier. So they have not big difference in the density, so they will just stay somewhere. Not much mass transfer will take place, because if one is heavier and other is lighter, definitely heavier has more gravitational pull. It will go down, and the lighter has less, so it will just somehow will be moving towards upward direction. But if they have same density, the gravitational force on those will be same, so definitely here not good separation will take place, as we want that light liquid enter from the bottom and it leave from the top. But in such case, when you are expecting like this density difference is low, so in such case there will be a problem. And then liquid viscosities are high. You know that when liquid viscosities are too high, definitely mean in this case liquid, yesterday we also discussed this point that mean mixing between two liquids will be very low, and definitely high viscosity. In case of high viscosity, one will move in only one streamline and other in other streamline, so they didn't get mixed properly, so there is no proper turbulence and no mass transfer will take place. So in all such cases, what we need, how we can overcome all these problems, is to create some agitation. You know, now we have to mix them. Our purpose is to increase the mass transfer. So what you have to do, you have to mix them together. You have to create some agitation, and usually that's called mechanical agitation. Mean we create this agitation with the help of some mechanical device, like we can just create turbulence by rotating it with the help of some blade or agitator. What will happen when we will agitate, we will mix it, it will increase the actually interfacial area per unit volume, and thus it will definitely decrease the mass transfer resistance. This what is interfacial area per unit volume actually mean, this is the area of contact between two liquids. Suppose just consider that two liquid has like very high viscosity, so they are just moving in streamline, and only the contact between those two will be just their surface, like one liquid. Suppose this is the column in which one is introduced, like lighter one, so lighter one is moving like in this direction and heavier one will be coming here, and so there will be very less contact between these two. Overall you can say they will be a bit mixed, but not that much. But if just I create some turbulence, I just create here start mixing them, so what will happen, their actually droplet size will decrease, and they will start mixing with each other. Their surface area will be exposed more, like, and they will get better contact with each other. When you look at such devices, you can even apply this such assistance on pack and plate column. Definitely you will be thinking how we can apply, like there are the plates and packing, so we can't apply somehow this agitation in between them, like rotating plates and but somehow they can be provided. But the easy way is, like for packed and plate column, you can provide agitation by oscillating pulse. Oscillating means you just create for a moment oscillation in that can be created actually with the help of sometime pneumatic like yesterday you have seen this figure. This was somehow for a simple spray column, but at that time, if you remember, I asked you to just skip this part, don't look at this part, because at that time there was no need. But now here is a need to look at this, why we have this part here. Like you can introduce air in this system. What will happen when you will introduce air? You just think about this, that there is a liquid in the beaker and you introduce the air. By installing a pipe, you just bubble air through this. What happens, the bubbles are formed actually inside liquid, agitation is created, so that agitation is actually creating somehow mixing. So with the help of this you can increase the contact between two liquids. So if we have packed and plate columns in all of those systems, this is the easiest way to create this agitation. Or sometimes you can also create agitation by mechanical means. We will look at one of the example. I think here we have that even packed tower is mechanically agitated. Mechanically agitation is with the help of rotor or blades or these impellers you have seen yesterday. So pulse perforated perforated plate or sieve plate column we have seen yesterday, and sieve tray or perforated plate column are used for this liquid extraction. So pulse perforated plate column are usually used in nuclear industry. So when you have plates in the tower, if you just remember from last lecture, we said that's out of all those systems which we have discussed yesterday, that was the best system. It was considered that provides much better contact mass transfer between the liquids, and that give better liquid extraction. So if we also introduce with that some pulse, like here we are just forcing air through this, and this is for some moment, then we stop it and then again introduce. So with the help of this you can increase the mass transfer, and they are used in nuclear industry. Okay, the most prevalent which are usually used here in industries, so those agitated column that imply rotating agitated. Means suppose if you are not using those static columns, like plates or packing base, so you can just use simple columns in which there is a vessel and there is rotating element. So they are usually used, and what they consist of, they usually consist of a shaft, and that is connected with some agitator, and shaft is actually at the top connected to some motor, and inside the column on the shaft are agitator or impellers, and this shaft is extended throughout the column, and when you will move it, you will rotate it, it will create agitation inside the whole column. The agitator creates mixing zone which alternate with the settling zone. You know, agitator are not continuously, they will be at some distance. So after some, you create this agitation, liquid will be coming in contact with each other, they start settling, then there is another agitator, and so on throughout the whole assembly there are agitators. I will just show you this stuff in some figures. Agitation can also be induced in a column by moving plates. Yeah, this is another thing, like this is one thing, like you have one shaft extended throughout the column, and that contains some rotating elements connected to this, like impeller or agitators. But sometimes agitation can also be produced by just you move plates up and down, like back and forth or up and down, you can move them, and with this definitely when you are just oscillating like one plate, you are moving it to the top and again bottom, so it will help us to create some agitation inside column, and that's one type of column we will discuss. I think that's the last type in which we can see such kind of movement of the plates, and you don't need to install like shaft and a lot of rotating elements. Just what you have to do just is to connect the shaft to some of these plates, and when you will move it, you create oscillations. So up to here you have seen that why we go for mechanical assistance. Just to summarize it, whenever gravitational force is not helping us much due to some problem like interfacial tension between two liquids is high, the density difference is low, or viscosities are very high, and in industry when you are such kind of problem are common. So in all those cases you have to introduce some external assistance so that it can help, or it can get add to gravity for better mass transfer. So in all those cases we have to go for mechanical assistance, and in mechanical assistance we have seen that there are various ways in which you can go for mechanical assistance. One is like to install a shaft, first one, like we have seen here, to introduce pulse, like you introduce something like air pulse throughout the column, and they are usually introduced through the like pack towers or tray towers, and we have seen that they have good application in nuclear industry. And then you go for next one, that's like agitation with the help of shaft and the rotors. So in this case they can be used in any column, and they create mixing. And final one, we said that we can move the plates back and forth, and this is the overall, you can say, the third way to create this agitation. Like first pneumatic pulse, then there is rotation with the help of shaft and rotors, and then there is moving plates. So this was the first column reported in the literature, which was designed by someone, Scheibel. So Scheibel column, first design overall. You will see here through this lecture that there were 3 designs. It was his first design. What does it consist of? Overall, you can see that this is just somehow peg tower. Yes, it is peg tower. You can see here the pegging. This is the sign of pegging you have seen already. So this tower consists of pegging, and you know that yesterday we said that with the help of pegging, when we jumped from spray tower to the peg tower, we said that this is good one. Pegging help us to improve the mass transfer, as well as it reduces the back mixing. So in such cases, when you are using packings, you can increase agitation with the help of disassembly. What is disassembly? This is just one shaft, rotating shaft, and it is connected with some of these rotating elements. You can see at various points. He is calling it turbine agitator. You have seen there were various type of main rotating elements in last lecture we have seen. So out of those, here it's using simple turbine agitator. They are just simple flat plates connected to this this shaft, and when it will move, definitely they will create agitation inside this, and then liquid passes through this packing, that is wire mesh packing. Overall, you can see light liquid is introduced from bottom, and it is leaving from somehow from the top, and heavy liquid is introduced from the top, and it is leaving from the bottom. So overall, here it is unbaffled. Maybe you will get clear idea when we jump towards second design, but here you can't see any baffle inside this system. So some column contain baffles. Actually, this column has one problem. At the end I will tell you, then we will jump to the second design. So it contains like flat bladed turbine type agitator. After some specific interval, like you can see, they are not continuous, like 2-3 are installed overall in the column, and they are connected to the shaft, and they create turbulence inside system. Then these knitted wire mesh packings, you know, that is packed column, so definitely it will contain some mesh, and they are in the form of wire mesh. So they prevent, already we discussed this, that packing help us to avoid back mixing, and as well as they also help us to induce coalescence and settling of the droplets, which are just created from here. Droplets are created from here due to this agitation, and then when they come to these packing, they will just start somehow settling. When settling means they start getting together. This means actually they start collecting to each other, or they start combining to each other. Then because they are combining to each other, what will happen? What will be the problem? Definitely it will create large droplet size. When droplet size is large, mass transfer area or surface area exposed for mass transfer is reduced, so you again bring it to next rotor and so on. So you can make maximum mass transfer. So already we have seen this, that this material which you select for the packing should be such that it is wetted all the time. Wetted means it will help us to increase mass transfer. If surface is wetted with one of the liquids and other is coming in contact, so better mass transfer will take place. So just look at this. These are the first and the second design of this Scheibel. So overall you can see in the first design, we have the column we have just seen here, that there is packing, and inside this there are like some rotating element, turbine impeller, and wire mesh. So overall you can see that if some liquid want to escape this turbulence, it will just try to move in this direction, through these parts, free parts. We have seen this, I think, somewhere in absorption column also, that in order to avoid these parts, or maybe in heat transfer we have seen such phenomena, that liquid escapes through some easy paths. So in order to avoid that, he has modified his design, and that was called his second design. So overall here the purpose was to introduce some more baffles. And this problem actually maybe in small column didn't happen, like liquid didn't escape. You can see, maybe you will say, okay, liquid is somehow in contact with this rotating element, but this problem was obvious in large size column. I will just come back to that slide. So large diameter column, if they have diameter greater than 1 meter, in all those towers, this was the issue. Because these rotating elements are not extended throughout the column. They are up to some extent covering inside column, but if you have to cover large area, definitely some of the liquid will escape, not will come in contact, and with this what will happen, efficiency will decrease. So in order to avoid this problem, we have introduced some baffles, and they were called internal and external baffles. So here you can see they have introduced some tie rods inside this assembly, and with the help of this they have connected some baffles on these. Baffle, you know that they are actually the plates which can avoid, or which can stop the liquid to escape through some easy path. So overall these are internal ones. Here maybe he has mentioned, but in next slide, okay, I will show you. These are internal ones. There are some external ones, because some of the liquid, okay, from here can't escape, but now you can see from this path it can escape. So they have also some baffles like here. They are called external one. They are connected to the external boundary. So this was improvement in design, and it will definitely help to improve the mass transfer liquid extraction of some component. Overall, just look at these. Here these are our wire mesh, and these are rotating blades inside the system. Then there were like inner horizontal baffle plates, as they are very clearly shown in the last figure, but there are some outer, like you can see here. Yes, liquid didn't get directly from this mesh to the next mesh, or coming from here to next mesh. It should come back to this path, and when it will come back to this path, here it will come in contact with this rotor, and then will move to this path, and so on. So with the help of this, overall mass transfer will be increased. This will be like liquid path. If we don't install like these horizontal baffle, what will happen, it will just go straight in this direction, and with the help of that, you will be decreasing the mass transfer, but with the help of these baffle we increase the mass transfer. So outer and inner horizontal baffle are used to divert the vertical flow. Vertical flow is in like this direction, as I have told you. If you don't install, it will start going in this direction, but we usually avoid it in these large size column with the help of these baffles, and it will promote definitely mixing and then liquid extraction. For system with high interfacial tension and viscosity, wire mesh are removed. This column can be just turned into the simple column with the rotating elements if we just remove these meshes. When we have seen these systems, we said that they are used to improve the mass transfer and to facilitate us, but if they are creating the trouble, like interfacial tension between the liquid is very high, as well as viscosities are high, so they will be providing more resistance inside the column. So in order to avoid that resistance, they can be removed from this Scheibel column. So overall, these first two design, initial design was improved by installing nothing, like just only introducing some extra baffles inside the column, and especially large size column greater than 1 meter. But these both design have one problem, and what was that problem? Actually, this didn't allow the removal of agitating shaft. This shaft which is agitating, we can't remove it just if like there is some problem, we have to inspect it, or we have to repair. What you were supposed to do, you were supposed to do dismantle whole column, remove it and everything through this column, and then you can check with this that if there is some problem, wear and tear, and you have to repair it. So this was one big issue in industry. So what they did, they have introduced another column in which allowed actually the removal of this rotating element, agitator assembly. You can remove especially the shaft and dismantle it easily in large size column, especially with the diameter greater than 1.5 meter. I think at the end of the lecture we have some diameter range. You can see that how much is the diameter used in industries for such kind of columns. So in such column, this improvement in design, so one figure is provided in your textbook. Kindly just check that. He has mentioned that overall assembly was improved in such a way that shaft can be pulled from this system, can be removed from this system, and that didn't impact all other stuff like packing as well as rotors. So that was one improvement in its design. and that was called third design of this Scheibel column. So this was one type of column in which we have seen that they are actually the combination of like packing and rotating element, and in order to improve mass transfer, some changes were made in the column with the passage of time. So after this, let's jump towards next one. Somehow you have seen this, if you can recall when you have seen this type of problem. Okay, let me tell you, we have seen in last lecture there was something mixer and settler column, and in mixer when I was showing you, we have seen this rotating disc contactor. Actually, rotating disc contactor consists of like rotating discs throughout the column, and there is nothing, just these are the discs in this column, and that's rotating shaft, and nothing, not like they didn't contain any packing, any plate or such thing. So they are simplest ones which we have seen yesterday. So they are also extensively used device worldwide, because they are simple in construction, and they can be used for this. But if you remember, at the end of that topic we said that they can be used especially when you need one or two stages. If you need more stages for some separation, then this is not the that suitable equipment. But if just one or two stages, they are widely used for that application. So what they have here overall, just let's look at this, then we will look at the details inside text. So in the figure you can see that there is simple column, and there are liquid inlet and outlets, light liquid in and out, and then there is heavy liquid in and out, and overall there is nothing like one shaft that is connected to a variable speed drive, variable speed motor. We can change its speed, and at the end we will see that why we go for this speed change. So this shaft is connected with some impeller or rotors, rotor disc, they are connected with this, and then there are some stator rings. Here you can see they are also fixed throughout the column. Overall here, you can see just they are like a slide, but just think over it like in a three-dimensional way, and they are overall inside this, they will be in the form of ring actually, and inside ring there is some empty space. This space is empty. So this is one complete ring actually, but inside that there is a hole for installing this assembly. So with this, what you do, just when you will start agitating this liquid, again here, if you don't have these rings on the sides, liquid will escape from this path, and some liquid will come in contact with this rotor, and with this mass transfer reduces. But when you install these, liquid can't escape. Liquid will somehow, you can say, liquid escapes from here, but overall this area is reduced, escape area is reduced when you install these stator rings. So these horizontal discs which are mounted on the rotating shaft, they have some specific diameter, and the ratio of disc diameter to the column diameter is 0.6. They cover, overall you can say that 60% of the column is covered by these rotating element, and then there was still 40% left over. Out of that, we have covered most of that 40% with these stator rings. The spacing, how away they should be, so that's calculated with the help of one formula, and that's based on again experimentations. People have observed that this is optimum, this provides better mass transfer. So that's this H is the spacing between these rings, these rotator discs. So not rings, sorry, usually mixed with this. This is rotor disc. Distance between these, or spacing between these, is 0.13 into dt power 0.7, and dt is tower dia, or you can say this column diameter. Column walls are connected with these stator rings, and how much opening, with how much part of these rings is like open. just consider a washer which you use with the nut and bolt, and that washer, that is empty from the inside, so that can be used as a stator ring. So almost it's like opening is 0.7 of the diameter. Overall you see that these discs inside rotor disc, they are 0.6 of the diameter, and this opening overall is 0.7 of the diameter, so it means there is still some space. You can easily pull out, you can just remove these rotor disc and shaft if you want to, for maintenance purpose or any other purpose. So droplet size control, yes, as I told you that this variable speed motor is installed at the top, and with this in this kind of specific column in rotating this contactor you have this assembly, so you can control the speed of the motor, and with that when you will control speed of motor, you are controlling actually the rotating speed of the shaft and the rotating speed of these discs. So if just think over it, just suppose you have some system and in which you are just creating the agitation. So if you increase the speed of agitation, what will happen? It will create more turbulence, and actually you are reducing the area, or sorry, the diameter of the droplets which are created due to this agitation. So if you want to create small diameter, very small diameter, definitely you will increase the speed, and if you want to control it like a bit higher diameter, so you will reduce the motor speed. Then next here is asymmetric rotating disc contactor. Asymmetric disc contactor or rotating disc contactor are actually modification of somehow the last one which we have seen, that is this rotating disc contactor. But there is one improvement in this design in order to improve mass transfer. So what is that improvement? They actually have different transport zone and contact zone. Contact zone, what is contact zone? Contact zone is the zone in which two liquids are coming in contact with each other. So overall in this column you can see they will be coming in contact in this area, as well as they are being transported, like someone is moving upward and other liquid is moving downward in the same area in which contact is taking place. But they have some modification. Overall you can see that here, just look at this diagram, it is more clear. Like if I just draw a line here, up to here, this is somehow the same assembly as you have seen for the last contacting device. So what is improvement here? They have just installed this one greenish one, you can see that's like one vertical baffle, and this separate two zones, one is this transport zone and other is like contact zone. And overall there is some settling zone at the top and the bottom of this settling zone is like for settling of one liquid, like which were heavier was entering from the top, and it will somehow settle down and then leave this column, as the lighter will move to the top, settle down somehow, and then move is removed from this column. Other is like same, you can see here there are stator and the baffle, this is vertical baffle, again agitated disc, and then there are some stator in order to avoid that escape of the liquid, as we have seen. So maybe this is this part is more clear in this diagram. You can see here, this is the part where contact is taking place, like this contact zone is shown here, contact zone, this all is contact zone, like, and then there is some transport zone overall outside this. But you can see here, from this just look at this, that suppose some liquid is coming from the top, it will be dropped to this portion here, rotation takes place, some mixing takes place, which is contact zone, and then this liquid is like leaving from here, and some liquid will be moving towards next, and then it comes to the next contact area, and so on it goes goes on throughout the column. With the help of this, actually somehow when you bring them here, some settling will take place, lighter and heavier will start separating, and then they come again here in contact, and their mixing is improved. In this kind of column overall, in these rotating column, they didn't contain any mesh or like packing as well as plates, so overall the problem was back mixing in such kind of column. So with such design, actually you can avoid somehow back mixing. Here only their mixing is taking place, and here transportations in separate areas, so back mixing can be avoided with the help of this assembly. And this design was also used in industry. This was modification of RDC. I think this is the last type of the column, and that's based on overall. Okay, if I just stop here before jumping to next one, I will just summarize up to here. We have seen that initially we said that we can have something pulse system in which you introduce the pulse. I have shown you one diagram for plate tower. Pulse can be introduced even in the spray tower that was shown. So with the pulse of air you are creating the agitation. Then we jump towards agitating element, and that agitating element was motor connected with agitators or rotors. So we have seen various systems that these mechanical agitation can be used even in the packed column. Inside, in between the packings, there you can install the system. And then we jump toward those systems in which you don't have any packing, like there are some simple columns and they have these rotating elements. So there were some design like RDC and ARD as well. I think your book has discussed another type of equipment. Just look at that if you are interested in more, but I think that's also more or less similar, so I have skipped that. The last one, if you recall that we said there are three ways to improve this agitation. First one was to introduce the pulse, second one was to create agitation with the help of rotor, and the third one, that was actually to create oscillation. You just move the plates or assembly inside the column to improve the mass transfer, and that's the main car reciprocating plate column is example of that. That was actually reciprocating stuff. We said back and forth motion, up and down motion inside the column. So how does it help us? Okay, let's look at this. Okay, first of all, look at the diagram. Here you can see that liquid heavy is entering and leaving from the system after settling through this part, as well as this main is moving and leaving. So overall you can see that here we have some drive assembly, there is some motor which is connected to the shaft, and that shaft is assembled in such a way that it is connected to the internal of the column. Here you can see they can be just simple plates, perforated plates. Perforated, they contain some of like holes through this, so this assembly is used for that system. And what is happening here overall, when you are just moving it, shaft is rotating, so this overall assembly is just moving back and forth, and with this agitation will be created inside this system. Due to this agitation, definitely mixing will be improved. So there are certain advantages of this system, and this was some of the latest technology inside industry. So what does it contain, or why we go for this? Rather than providing agitation by impeller on a vertical shaft or by pulsing, this car, some scientists, they have devised a reciprocating device, and that reciprocating device actually consists of perforating plate extractor. Perforated plate this is plate column actually, and if you remember, that plate column was discussed as our sieve tray column or plate column actually, that was discussed as the best among all other we have discussed yesterday. So if we just improve agitation in that main system with the help of this assembly, definitely we can go way ahead in terms of mass transfer. So here the main advantage of this system is that this system uses less energy. When you have a lot of impeller connected to the shaft, so you have to provide more energy to rotate whole liquid, but there in small portion of this main equipment you are just moving back and forth some assembly, and with the help of this you can create more agitation inside the liquid. So another advantage of this is there is close spacing of the plates. So when plates are close spacing and you are creating more turbulence here, and when you are creating more turbulence, definitely you are increasing mass transfer, as well as because plates are close to each other, some mass transfer takes place, and then liquid is jumped toward next plates and so on. So here axial mixing is avoided, or back mixing is avoided in this system. So these perforated plate actually contains large hole. This car reciprocating plate system actually contain large hole, and they are of the size 9/16 inch. In this compare, if you are concerned about this large hole, if you consider or compare it with the distillation or absorption, you can get the idea. And the overall hole area on the plate is typically 58%. So large number of holes are available there, so easily liquid can pass through and can also make good mass transfer. Mean this central plate which support both sets of the plates is reciprocated by a drive. I have already shown you. There is some driving motor at the top of the column in which just reciprocate these plates. As well, these columns are particularly they are particularly useful, or they are commonly used in bias separations where actually residence time in these columns is small. You can see as we are using the plates, and in the plates we said that they are the more efficient column. When something is more efficient, definitely just in terms of this assembly, small in size, just look at that, recall that distillation. When distillation column is not efficient one, you need more good separation, and that's difficult one. So what you have to do, you have to increase the size of the column. But if it can maintain that purity, or it can give you specific purity in small assembly, so that's the beneficial one. And with the help of that, actually residence time is decreased. So this in bioseparations, residence time, if you give less residence time, that's good for you. So residence time is decreased, and these columns are widely used in these bioseparation industries. If you recall from the first lecture, we said that this liquid-liquid extraction is commonly used in three type of industries. In two type of industries it is commonly used, and some other industries it is somehow used. And out of those two industries, one was petroleum industry, and other was this biotechnology industry. So this type of car reciprocating column are used there widely. So up to here we have discussed all type of these systems. Now let's look at them, that based on their industrial application, what are their size and how much amount they can handle, amount of liquid actually in per unit area. So just look at this. This is based on the data collection from various industrial plants. So overall you can see these are various column types which we have somehow discussed. I think maybe one is these one or two are not discussed, but all other are discussed here throughout last lecture and this lecture. So overall their comparison is two information are provided: maximum combined liquid throughput. What does this mean? How much overall amount of maximum combined, both liquid and the solvent, feed and the solvent, overall combined liquid, amount of the liquid per unit area per unit time handled through that column. As well, there is maximum column diameter provided to you. So overall you can see here that different columns have different range. Why we can't have same? Because there are some limitations. Suppose if I say, okay, I want to handle large amount of the liquid, but I will handle in this one specific equipment, that will maybe not provide good mass transfer if you are handling very large amount of the liquid. So somehow based on that, there is some differentiation between these systems. As well, there is the column diameter limitation. One of the limitation, as I discussed in the Scheibel column, that there is, if large size column you are using, so in that case some vertical flow of the liquid starts and your mass transfer is reduced. So in those cases there are some limitations on diameter, that maximum diameter what is being used, and this is from industrial data. So overall you can see there is wide range of diameter from 3 meter to 8 meter. Various columns are being used. So based on this information, as well, you have this information is also provided that there are advantage of and disadvantage of different extraction equipments. So you can see that we have here like mixer settler, the first assembly which we discussed, they were based on actually mechanical agitation. So they have some certain advantage, they have good contact, handle high viscosity liquid because they have rotating elements. So they are good with even high viscosity and interfacial tension liquids. So they can handle wide flow rate as well because they are good large size vessels. There are various other advantage also, but there are some disadvantage, like they have large hold up. I mean, inside them large amount of the liquid is holded up, so then it will come out of this. Suppose if you are using it continuously, I mean, there is any other operation after this, so definitely large amount of liquid is captured inside this. When it will pass through this, then will come to the next liquid. And the high power cost, because they have rotating element, rotating blades, and that cost high power cost, as well as higher investment, and large floor space is required because they will be large in size, in order to improve the area of contact. So these are certain disadvantages. And then we have seen yesterday there were continuous static columns. If you remember, they were spray, packed, and sieve tray type. So they have somehow, as this is by the way as compared to each other, like low initial cost, maybe you will be thinking columns are they cost too high, but as compared to each other their cost, like they have low initial cost, like this has high investment, definitely its cost is higher as compared to these columns. So low operating cost because they are just column and you don't have rotating element inside this, so overall operating cost is not that high. And simplest construction as simplest actually because you have also wide application of these in absorption distillation, so easy to construct. You already know well about these kind of systems. And high throughput, but they can't handle very high flow rates, as well as high headroom is required for them, low stage efficiency, and difficult scale up. So they have some limited application in terms of this. Why they can't handle high flow rates, if you remember, like we have in distillation type of equipment, like this will create some problems of like flooding and various other problems. So in order to avoid that kind of problem, you go for some like small amounts handling in these systems. And then there are continuous counter flow contactor with mechanical agitation, as more or less mostly we have seen today. So they have good dispersion because they have rotating element, and then there is reasonable cost. Somehow you can say they will be in between these two because they were somehow modified form. So many stages possible, as well as relatively easy to scale up, but they have limited throughput with small density differences. Can't handle emulsifying system sometime, and then emulsifying system actually will be those systems which causes large or heavy emulsions. And we have seen this yesterday, that if there is heavy emulsion is formed, that two phases are not actually separated, this extract and raffinate. So those system then will be problem here. And why strong emulsion is formed, if you remember, we said that in those system in which we have mechanical agitation, so due to this agitation you can sometimes create very high emulsion, large emulsion. So due to this, maybe some of companies have modified and they have rotating motor with the variable speed, so you can control this stuff. And then there are somehow centrifugal extractors, they are also used. Overall, based on all this discussion, advantage and disadvantage of various equipment, and the last slide which we have seen about the various designs, capacities available about this system, there is one figure in your book, that is figure 8.8, and that is about selection of the equipment. Suppose you are in industry and you have to select one equipment. How you will select that equipment? After collecting some initial data, you can come up with this, that you can see how much is your maximum combined throughput, as well as how much space is available, that what can be maximum diameter of your equipment, as well as based on various other advantage and disadvantage discussed here, maybe based on cost, power, and that stuff, you can select the equipment. And just go through this diagram quickly after going through this stuff. I didn't show here, but just quickly see that he has mentioned certain factor, like if this applies, okay, go to this path, otherwise if this applies, go to the next path, and so on. So up to here we have discussed all this stuff. Initially liquid extraction equipment, liquid extraction simply introduction. Then with equipments we are done with this. By next lecture we have to start with the design. And this is also the end of this first week lectures, like we have completed all 3 lectures. So if you have any question, you can drop me by email, and if there are questions by many people, I will just again record a lecture for all those question answer and will send you. But if there will be question by one or two people, I will just reply them, and otherwise there are if more than 2-3 questions, then I will just record answer of all those questions and will post it, so it is advantageous to all of you. So up to here we discussed like mechanically agitated, mostly the equipments which we have discussed today, they are mechanically agitated equipments, and then we have discussed their advantages and disadvantages for the and selection of equipment. At the end we have seen that how we have to select, we have to look at various factors, their somehow design limitations as well as their advantages and disadvantages, and then we can go for one specific equipment. So at the end again thankful here to the same company from where we have taken these very good explanatory images. Thank you so much.